Welcome, Mr. Sutton here, bringing you the AB Calculus 3-3 Classwork Extra Practice Solutions on Differentiability Part 2. For this problem, we're given this graph of f, and we want to know which statement is true. So let's just go through statement by statement and see what we can eliminate. First one is basically saying that the derivative at a exists. This is the limit form of a derivative. Well, we have a discontinuity here, so the derivative is not going to exist. F prime of a is d and e, so that's an issue. For part B, or answer choice B, they're saying the left and the right side limits don't match up. That's not true either, because we are heading toward the same place, this open dot here, as you get closer to a from the left and the right. So since we're approaching the same y value, we can eliminate choice B. Choice C, they're saying that the limit as you approach a and the function value at a do not match up, and that is true. We're approaching the hole here, but the function value itself is down here somewhere. So the limit and function value are different, meaning choice C is a good answer choice, but let's look at D just to be on the safe side. D, they're saying the limit does not exist, and that is false. The limit does exist at this hole. It's whatever this y value of the hole is. So that means choice C then. For this problem, we're told that f is a differentiable function and that f of 3 is 8 and f prime of 3 is 5. So which statement is false? So we have statements about the limits. These appear to be statements about derivatives. So let's analyze what they've given us here. Since our function is differentiable, that means it is also continuous. And since our function is continuous, that means the limit exists. It means specifically that the limit as x approaches 3 and f of 3 are going to equal the same thing. They're both going to be 8. Because that's what it means. Continuous means your limit and your function value match. If our limit exists and it equals f of 3, well, that means a few things. For one thing, choice A can't be false because f of 3 has a value of 8. So if we're saying the limit equals f of 3, it equals 8. And choice B also can't be true because the limit exists, so the left and the right side limit have to match up. So we can eliminate A and B. Now these next two statements here, they pertain to this f prime of 3 equaling 5 business. If f prime of 3 equals 5, we're basically saying the instantaneous rate of change, which both of these expressions represent, is going to be 5. And if you had trouble seeing it, you can think of this as f of x minus f of 3 over x minus 3, or f of 3 plus h minus f of x, or f of 3 rather. So if you write it like that, this is definitely saying the derivative is 5 at x equals 3. So that eliminates choices C and D, leaving us with only E. Now E is a little bit tricky because they're saying the limit as x approaches 3 of f prime equals 5. And that's awfully tempting to say that that could be true because f prime of 3 is 5. And we're differentiable. So differentiable does not mean that f prime is continuous. It means that f prime has a limit that exists at x equals 3, but it doesn't necessarily mean that the limit as x approaches 3 of f prime and the value of f prime at 3 have to be the same thing. They could be different, and this function would still be considered differentiable. So for that reason, we're going to pick choice E, because that could be false. On this problem, we're given this piecewise function, and they want to know what's the properties of this function at x equals 3. We've got undefined, continuous, differentiable, and some combination in between. So let's test for differentiability, and that will include continuity on the way. To start this, I need the left and the right side limits as x approaches 3. So left side limit at 3, that's going to be 3 plugged into this lower rule of x squared. So that's going to be 3 squared, which is 9. Right side limit at 3, we're plugging it into the greater than rule now. That's going to be 18 minus 9, which is also 9. And since we're talking about continuity, we need to talk about f of 3 as well. F of 3 is going to be the same as the right side limit because of the equals here, so that's just also going to be 9. So we see here that the limit as x approaches 3 and f of 3 match up. That means that our function is continuous at x equals 3. So let's keep going, because we also have differentiability as an option. And by the way, some of these can be eliminated. If they said, for example, differentiable but not continuous, well, if something's differentiable, it is continuous, so you could eliminate C at the very least. All right, let's check to see if the derivative limit exists. left side limit of f prime at 3, that's going to be whatever I get when I plug 3 into the derivative of x squared. So plug it into 2x. That gives us a left side limit of f prime of 6. Right side limit of f prime, now I need the derivative of this lower function. That's going to be 6 as well. Since those two limits match up, that means that our function is going to be differentiable at x equals 3. So continuous and differentiable, choice E. On this problem, we're given this piecewise function and we want the value of f prime of -1. In order to figure this out, we need to first verify that f is differentiable at x equals -1. The only reason we have questions about it because it's a border value, so we know there's possibilities of cusps and discontinuities and all sorts of other craziness at these border values. So let's go ahead and check the limits first. Left side limit as x approaches -1. That's using this first rule. That's 3 times -1 plus 5. -3 plus 5 is 2. Next, we have the right side limit. Now we're using this bottom rule. That's -1 squared, so -1, plus 3, which gives us 2. F of -1, which we also need to verify continuity, is going to be this lower value that we get when we plug -1 in here again. So that's 2 again. We see that the two-sided limit as x approaches -1 and f of -1 actually do equal each other. So that means we're continuous at x equals -1. So let's keep going and figure out if the limit of the derivative exists. So left side limit of f prime as x approaches -1, that's taking the derivative of this top rule here, which is 3. Right side limit of f prime, now we're taking the derivative of the bottom rule. So I'm taking, I want the limit as x approaches -1 then of -2x, which is going to end up being 2. Since the left and the right side limits do not exist for f prime, that means that we're not differentiable at x equals -1. So f of -1 doesn't exist, or f prime of -1 rather doesn't exist. So choice E. On this problem, I'm trying to find the value of f prime of -1. Since this is a piecewise function, we need to check differentiability before we go ahead plugging -1 into the derivative of either of these rules. So let me check my left side limit first, because I'm going to check continuity before differentiability. So left side limit as x approaches -1, that's going to be 2 times -1 plus 5, so that's going to be 3. Right side limit, we're going to have -1 squared, so -1, plus 6, which is 5. And we see right away we're kind of dead in the water here. These limits don't match, so that means our overall limit as x approaches -1 is DNE, does not exist. If the limit does not exist, we're not continuous at x equals 1. And if we're not continuous at x equals 1, we're not differentiable at x equals -1. And if we're not differentiable, it means we can't take the derivative at x equals -1. So this is E, non-existent. On this problem, I'm given this piecewise function with these mystery constants m and b, and we're given that this function is continuous and differentiable at x equals 1. They want us to figure out the values of m and b based off of that. So one way to do this would be to plug in all these answer choices and test each time for continuity and differentiability. Another way to do it is just to pretend you're testing for it right away and leave b and m around until you get some equations that you can use to solve for them. So I'm going to pretend I've got a continuous thing that I'm proving here. So let me start by plugging in, doing my left side limit as x approaches 1 from the left of f of x. So that's going to be plugging 1 into this first rule. That's going to be 1 plus 3b plus 2. So basically 3 plus 3b. And then let me check my right side limit as x approaches 1. That's using this bottom rule here. So that's just going to be m plus b, because I have m times 1 plus b. So we know, and also let's just throw in the function value, f of 1. That's going to match the top rule here, which again gave us 3b plus 3. All right, if this is a continuous function, these three things have to match. So that means that 3b plus 3 and m plus b have to equal each other. Can't really do a whole lot more than that to solve at this point. I'm going to need another equation. To get that other equation, I'm going to compare the limits of f prime, because those have to match as well for this to be a differentiable function. So left side limit of f prime, if I take the derivative of this top function here, this 1 gets zeroed out. We end up with 3b plus 4x. And I haven't actually taken the limit yet, but that's the derivative I'm going to plug 1 into to take this limit. So this ends up being 3b plus 4. Next, my right side limit. Well, now I'm taking the derivative of this bottom function. So that's just going to be m, and the b gets zeroed out. That means that 3b plus 4 and m must equal each other. So now I can plug in 3b plus 4 for the m value up here in the original equation. So moving that down here, we have 3b plus 3 equals 3b plus 4 plus b. And let me just simplify a little bit. This is really 4b plus 4 on the right side. So doing a little quick algebra, I can subtract 3b from both sides to get b. I can subtract 4 from both sides to get negative 1. So b is negative 1. Now that I know that, I can plug it back into this equation right here that has m all by itself. We can say m equals 3 times negative 1 plus 4. Well, that means we really just have negative 3 plus 4, which is 1. So b is 1, or actually b is negative 1, m is 1. So that's going to be choice B. Too many b's. For this problem, I'm being asked to find values of a and b that make this function differentiable. So I'm basically going to pretend this is a differentiability test. That's going to give me some equations that I can use to solve for a and b. So let's go ahead with the continuity part of the test. Left versus right side limits. Left side limit as x approaches 2 from the left. This is going to be 2 plugged into this lower function up here, or I should say the lower x value function. So that's going to be a times 2 squared, so a times 4, 4a plus 10. Next, the right side limit, we're using this bottom function. So that's going to be, let's see, 4 minus 12 is negative 8. We have a plus b, so negative 8 plus b. And since I'm actually doing this free response style, and I'm looking to show continuity before differentiability, I really do need to include something about f of 2, just to show that whatever result I get out of this comes from me testing for continuity. So f of 2, fortunately, is just the same as this bottom function here with the right side limit. So this is negative 8 plus b again. All right, so if this thing's continuous, all three of these things need to match up. 4a plus 10 needs to equal negative 8 plus b. I've got two variables, so I can't really do much to solve that yet, but at least gives me an equation I can come back to. To get another equation to play off of this one, let me now look at the limit of f prime from the left and the right. Limit as we come from the left of f prime, that's the derivative of this top function. So that's going to be the derivative of the limit of 2ax. And if you actually plug 2 into that limit, we end up with 4a. Next, the right side limit of f prime. That's going to be the derivative of this lower thing with 2 plugged in. So 4 minus 6, and the b gets differentiated away. Or 2x rather, minus 6, I should say. And if I take the limit and actually plug 2 into that, I get 4 minus 6, which is going to come out to negative 2. Since this is differentiable, it means the slope limits have to match. So 4a and negative 2 must have the same value, which means a is going to equal negative 1/2. Well, now that I know what a is, I can plug it back into this equation up here. So I can rewrite this as 4 times negative 1/2 plus 10 equals negative 8 plus b. 4 times negative 1/2, that's negative 2. Adding that to 10 gives us 8. Adding the 8 from the other side gives us 16. So there you go. A is going to be negative 1/2, b is 16.